Good afternoon, ladies and gentlemen. My name is Dwi Irmawati Gultom, and I will be the moderator for this afternoon session. Today's session specifically provides essential knowledge that can help participating government officials to gain the key element of technology commercialization. The goal is to collaborate with private companies in the process of co-creation of technological innovations. In this session, we will have 6 speakers with regard to technology transfer and commercialization. Each speaker will have only 10 minutes to talk, and I will kindly remind all speakers if you have 2 minutes remaining. Ladies and gentlemen,
recording in progress.
For our first speaker, we have Mr. Mehtab Ahmed. He is Senior Technical Officer from PCSIR Labs, Pakistan. In this afternoon, Mr. Ahmed will talk about application of business incubation centers and technology park on the establishment of small and medium enterprises and economic development of any country, a case study. Mr. Ahmed, the time is yours. Mr. Ahmed, I'm sorry, you need to unmute yourself, please. You still muted? Host, the organizing committee, could you please help Mr. Ahmed to unmute himself? Yes.
Assalamualaikum.
Waalaikumsalam. Now we can hear you.
Thank you.
Please proceed. Thank you.
Thank you, Doctor. Can you see my presentation on the screen?
Yes, we can see your presentation. Thank you.
Thank you. First of all, I congratulate the organization who organized such a brilliant international workshop on technology transfer and commercialization and play key role together us. Today, which I am going to share with you, the study application of business incubation and technology parks on the establishment of small and medium enterprises and economic development of any country, a case study. The study was done by me along with my colleagues Ejaz al-Haq, Zainal Abdin, and Zahid Ali Chennar. As we all know that in the contemporary era, developing countries are striving to accelerate and encourage people to become entrepreneurs for socio and economic development of their country. According to Small and Medium Enterprise Development Authority, which was established for encouraging and facilitating the development and growth of small and medium enterprises, that Pakistan needs growth of global competitive SME sector through a conducive environment and support services which may serve as an engine of sustainable growth for nation of the company. All the theoretical as well as empirical studies, suggestions, and results supporting the significant contribution of SMEs to economic growth. Therefore, SMEs are considered as a backbone of economic growth and play a major role in generation of employment.
Mr. Ahmed, I'm sorry for interrupting, but could you please make the presentation in a presentation mode?
Yes, I am coming. Sorry. I'm just telling you that SMEs are a major tool to develop the economy of the country, and studies shows that incubation system plays major role to growth the SMEs, and SMEs plays major role to generate employment as well as economic development of the country. Uh, the problem behind this study is that Pakistan has more than 115 universities, and every year they generate 0.4 million graduates in different fields. They have different ideas, they have different research, but there is no any roadmap to give them guidance, mentorship to convert their knowledge or research in the products. Therefore, the objective of this study to highlight the silent future of business centers and technology parks for the development of SMEs. And research question is same the incubation centers role for the establishment of small and medium enterprises. All literatures in favor of the business incubation centers, and business incubation centers play significant role for the development of SMEs and entrepreneurs. The methodology is studies of literature review and a case study of Pakistan Council of Scientific and Industrial Research. Business incubation in the generation of job creation, definitely when we help SMEs to develop, automatically the jobs may be created. Okay, I'm coming on the case study of Pakistan Council of Scientific and Industrial Research Drive-in Technology Business Incubation Center. In 2005-6, PCSIR realized that no entity, businessmen ready to get locally developed research and convert it into the products. The reason was behind that they don't believe or prefer the local technology. Unfortunately, in developing countries, everyone prefer the technology or process of developed countries. They don't trust on their scientists. Here I am going to inform about PCSIR, that PCSIR is Pakistan's largest R&D organization engaged to develop the product process through indigenously resources. Its vision to produce cost-effective technologies, and objective is utilization of indigenous resources for the development of product process and promotion them. PCSIR has many laboratories for research. Overall, the Pakistan's more than 11.
Sorry, sir. Your screen is not a full screen.
Sorry.
Yes. Please full screen your screen.
PCSIR has many laboratories to conduct the research overall Pakistan, and they have also degree awarded institute and vocational institutes. The major activities of PCSIRs are technologies development, technical services, troubleshooting for industries, human resource development, testing, calibration, and support other institutes. We are also providing services as per WHO and ISO standards. PCSIR is also certified ISO 17025. PCSIR has a technology business incubation center. As I told you earlier, that nobody was ready to purchase the process or technology and convert it into the production. Then we follow the model of developed countries. They invite in PCSIR for nurturing. PCSIR provided them full facilities such as technology transfer, supervision, and also nurturing facility for the registration their products for commercialization and whatever they needs. PCSIR tried to grow them like a kid. Initially, PCSIR has two incubators which were provided the services from PCSIR. They purchased technologies from the PCSIR. First one is Rain Neutro Pharma and second one is Swiss Pharma. They invested few amount for the purchase of technologies and PCSIR provided them space and the equipment and machineries required for the processing was provided by the party. Here I am on the screen, you can see the summary of two incubators. They come in PCSIR. Rain Pharma come in PCSIR in 2008. They have had invested only 2.7 million. They purchased process initially 3 products and shifted in the industrial zone 2013. Now they have more than 170 products for the production. They create jobs, in-house job in the factory, more than 45. They are producing 10 products, import substitute, and also some products are exported by them. And the same second party came in the PCSIR in 2009. They invested only 3.7 million. They acquired 8 processes, shifted 2013 in the industrial zone. Now they have more than 150 products, created jobs, import substitute products, which is very important for the developing countries. They are producing import substitute product as well as exporting the products. The conclusion of this summary is incubation centers are very important for developing countries because SMEs are uneducated, or we can say not well educated. They are required to help on every step, production to marketing or exports. We should provide them services for each steps what they needed. In developing countries, you know, we all know, we are focusing only to develop the product, develop the process, research, but we don't know which product, which process is ready is helpful for the commercialization and helpful for economic growth and creation of jobs. We don't have a expertise to market, commercialize the products. We don't have a way to commercialize the product, only focusing developing the products or process or technologies. My conclusion, my recommendations are that we should focus on commercialization of the product and develop demand-driven products, which need our society and which play a role as import substitute or export oriented. Therefore, through this study, we understood the business incubations are socio-economic development entities to support potential startup SMEs, help them like a kid to growth, accelerate them to establish and make them success for providing comprehensive program. In this regard, proper policies should make and ensure implementation and support community. Not only Pakistan, but developing countries are many ideas, opportunities, research, innovations, potential personnel, but only need to manage it and establish proper and transparent system for playing role in developing community as GDP. Thank you very much. Thank you.
Thank you, Mr. Ahmed. For next speaker, we have Dr. Bambang Pamujati as the Vice Rector for Research, Innovation, Cooperation, and Alumni from Institut Teknologi 10 November Indonesia. In this afternoon, Dr. Bambang will talk about escalating ideas toward innovative products and its commercialization. Case study of ITS Surabaya. Bapak Bambang, the time is yours. Mr. Ahmed, could you please stop sharing so Dr. Bambang can share his screen, please?
Sorry?
Could you please stop sharing your screen? Yes, thank you very much. Bapak Bambang, the time is yours.
Yes.
Okay, thank you very much. Can you hear my voice clearly?
Yes, we can clearly hear you. Thank you.
Thank you very much. Oke, selamat siang. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, good afternoon, everybody. Thank you very much for the opportunity that is given to me to present escalating ideas toward innovative product and its commercialization. And I take the case study of my institution, ITS Surabaya. My name is Bambang Pramujati. Currently, as a Vice Rector for Research, Innovation, Partnership, and Alumni of ITS Surabaya, Indonesia. The background of my talk, why I think the innovation, or we think in ITS innovation is becoming more important to us, is actually the mission of our institution. We want to be an entrepreneurial university in 2035. So by now, by the end of our, I think we are, so by 2025, we hope that we will be able to be a research and we try to transform our innovative research into innovative for the research policy. Now we have the innovative product-based research. And then by 2035, where we hopefully become the entrepreneurial university, we will be able to commercialize our innovative product, and those become the main revenue generation of our academic and research. For now, currently, for sure, our main sources is the sources from the student as well as the collaboration with the industry. But hopefully, if we become the entrepreneurial university, then we will be able to have product that can be commercialized or available in the market. Before I talk later, I guess all of you also have the same thing. We have the researcher and we have the innovator. People said, or at least this Jeff Nicholson from 3M says that researchers or research actually turns money or transform the money into knowledge, while the innovators transform knowledge into money. It doesn't mean that we prefer to have innovator or vice versa, but I guess those has to be able to be available in institution, research institution or university, such that we make sure that the source of innovative products are always available, provided by the researcher, and then the knowledge that's available can be turned into money by the innovator. That's the ideal thing. So we have to have those two clean, either clean and the red person here. Although they have actually different person and different skill, probably you cannot this in our institution or in your institution. For sure, that one people tend to be a researcher and one people to be tend to be an innovator, and that I guess that's very common. And then the innovation and commercialization. If we talk about innovation, means we have new ideas, we have new technologies. It's very important, that's for sure. But without commercialization, then there's no new ideas or new technology. The more important thing is that those inventions must be commercialized. The invention could be the output of a research, the development, study, implementation, and so on. And then for sure, it's required protection of intellectual property right, which could be those for IP. And then the product could be for sure the tangible product, which is the prototype or the intensification, which is the process of introducing a new product or production method or idea into commerce, or we can say making it available on the market. For sure there's economic value, so there's a valuation and all those things within the commercialization. So basically, when we can put our invention into commercialized product, then actually we try to solve the real problem, because then it means that the one or the product that we have is accepted by the society. When we talk about the commercialization route, this is a general commercialization route from the input and ideas, and then finding research and engage with TTO or technology transfer office, and then the innovation disclosure form, we have a novelty, and so on and so on. Until at the end, we have the negotiate commercial agreement. That's basically the general commercialization route that probably most of the innovator will have to go through before they will be able to commercialize their product. In ITS, probably similarly in ITS, we have how we transform or how we escalate from ideas into innovative product. We have a Directorate Research and Community Services. Sorry. We have the Directorate Innovative and the Directorate of Research and Community Services, which is working on the research, basic research with technology readiness level, probably from 1 to 4 to 5 and so on. And then we also have the Center of Excellence, or in Indonesia we call it PUI, Pusat Unggulan Iptek Perguruan Tinggi. And then from this Directorate of Research, which consists of research center, we will have the excellent output, could be based on the science and technology, and then from there the excellent output can be sent into the Science Technopark of the Directorate of Innovative Innovation and Science Technopark, which lead to a product, to a diffusion. So once the TRL is increasing from 6, 7, 8, and 9, then we will be able to diffuse. Some of them still in Indonesia, and then we will have 3 different options, whether we will have the product that can be sold directly into market, or we can have a partnership with industry to mass production, or we can actually initiate a spin-off company. So those three things are actually an option that we have in trying commercialize our product. The partnership could be partnership with the industry for sure, could be partnership in the industry, but we can also have partner with the government and the etc. So basically, that's how the ideas come into innovative product in ITS. So from TRL 1 to 3 up to 4 from director research, and then went into the higher technology readiness level until it's ready to be product. If it's possible, we produce ourselves. For example, our robot Raisa, it's our own production, but the rest we have a partnership. And a few important or key elements, we see those things are important, but we have to have things that will be able to support or to accelerate those things. So the few key elements that I think it's important. One thing is the policies. We have to be able to have a supporting policy. So within this research and university, innovative university goal, we have this kind of policy. And then we also have another policy. We try to support, build the supporting governance, how from directorate 1 and directorate the next directorate work hand in hand, such that we will have the commercial product, which can be unique product, is own production or joint production or becoming a startup. We have our own startup in 2017 ITS with the ITS Technoscience. And then this is in terms of research, we have a different kind of policy. Usually we rely on the researcher to have their own research, but now we also have a top-down scheme. We have a consortium research center, and we also have this example of the top-down scheme. We have autonomous car, and I put last year. This year we have intelligent healthcare. Next year we will try to have intelligent industry and so on. We also have the key element, which is the resources, could be the human resource and the facility. We have several faculties and department. And then the organization has to be designed such that it's allowed the development of product, innovative product from TRL, low TRL into higher TRL, controlled or managed by the innovation center. And then also this is an important or key element that we have, which is the organization, the research and innovation profile that we have. We have a 10 research center, we have 5 center of excellence, we have 5 science cluster innovative in the maritime, in the science technopark, and then we also have 5 study centers. So these are the resources that we have in order to enhance our commercialization product. And then we also, this is also important thing that we think is the environment, innovation ecosystem, which includes, we should be able to have the good relation with the industries, with the business, with the government, the capital provider, with incubator, etc. So those things are several key elements that I think is important, because our time is very limited. So this is few key element that we have, and then this is, for example, few example of our innovative product. One is the ISO. This is storage planning. It's the first, I think, the first Indonesian certified storage planning. And then we also have this integrated disability design for medical application. It's an cardioplastic surgery and all those things. And then this is another important manufacturing partnership. So we design all the sectorial interior of the light train, and now it's being mass production by other companies. And then we also have this monitoring system, automation monitoring system for safety, and has been in the market. And our biggest customer is PT Pertamina, the oil company owned by the state-owned oil company. And then this is the one I show you, the iCar, autonomous car and autonomous boat. The autonomous boat now being certified by the industry, and the autonomous car next being produced for the commuter inside the campus. And I guess that's to conclude my speech. Sorry, exceed 1 minute. Thank you very much, Mbak. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Pak Bambang. It's a very interesting presentation. For the third speaker, we have Mr. Prabath AB Siriwardana as Deputy Director of Ministry of Skill Development, Vocational Education, Research and Innovation, Sri Lanka. Mr. AB Siriwardana will talk about key performance indicators on technology transfer and commercialization of research towards sustainably commercial agriculture. Mr. Abe Siriwardana, the time is yours.
Thank you, Dr. Gulton, for nice introduction. I will share my screen now. And I think you can see the screen now.
Yes, we can see your screen. And it will be great if you can make the presentation mode of your screen. Thank you.
Okay, now you can see the full screen, I think. Okay, hello everybody. I'm Prabath, and my co-author is Professor UK Jayasinghe Mudalige from Sri Lanka, and my research topic is key performance indicators on technology transfer and commercialization research towards sustainable commercial agriculture. And also I take this opportunity to thank the workshop organization to select me to present my presentation. And this is the key figures of agriculture sector in Sri Lanka. Usually the 7% of national GDP is contributed by agriculture sector, and it is crops and other 5.2%, and fisheries 1.2%, and livestock sector about 0.6%. So this makes Sri Lanka to identify increased productivity in the agriculture sector as one of its top priorities as a development country. It is very important to convert agriculture from subsistence to commercial level, because it supports food security. That is for security SDG number 2, zero hunger by 2030. In this regard, we know that research institutes play a major role in technology development and product improvement. So it is very important to assess and manage performance of especially technology transfer and commercialization of research institutes work. So here we identify that we know that there should be some indicators. So it's best to use key performance indicators to induce organizational good research practices. First, we conduct a literature review on performance measurement using 65 research papers throughout the world, and actually to identify role of KPI for improved research institute on commercial agriculture research. As you can see, this is a publication on that, and accordingly that literature suggests that commercialization, technology transfer, research collaboration, research for society as 4 most important key performance drives in the commercial agriculture field. So here is our research problem, and that is role and position of technology transfer and commercialization. So we think that it is a problem actually. Is it properly to know, is it properly understood in research institute of developing countries like Sri Lanka, and also is it properly measured in research institutes, especially in Sri Lanka, for decision making? Based on this problem, we formulate the research question. Actually, what is the role of technology transfer and commercialization? in research business as key performance driver of research institute in Sri Lanka towards productive commercial agriculture. Then what is the position of technology transfer and commercialization in the research culture of the research organizations, and according to the leaders' perspective, how they see this technology transfer and commercialization, importance of this technology transfer and commercialization. So this is how we get the data. First, we conduct in-depth interviews, personal interviews, using semi-structured interview schedule through online video conferencing facility, and it is actually about 45 minutes to 1 hour interviews, and because we selected head of the research institutes because they are influential in KPI formulation and make informed decision towards research development. So this inquiries, there are 15 inquiries, there are 15 questions covering making decision on KPI, KPI formulation, KPI reporting, KPI measuring, KPI establishing. And this questionnaire was validated by 6 eminent person expert panel. So here is our data findings and presentation. It's in a brief. And it was found that majority of institutional leadership did not practice KPIs in its decision-making process at a matured level. I should stretch at a matured level. So 90% of them saying institutional level KPI was not properly assigned to measure commercialization aspects. No common and sector-specific performance drive for technology transfer and commercialization of research in research institute. For example, our field, it's commercial agriculture field, so there is no common and sector-specific performance indicator for technology transfer and commercialization. No specific strategy to plan, implement, monitor, and manage commercialized research outputs. However, a wide range of KPI-related benefits in the commercialization aspect of research acknowledged by them. For example, research sustainability, institute sustainability, society acceptance of the research, competitiveness in research development. Those they acknowledge actually there should be a KPI to measure towards these things. So we, based on our results and information, we propose these policy interventions. That is, first, rapid adoption of the latest technology from other countries, coupled with enabling more local technology transfers, more local innovations. Then bulk R&D investment from industry rather than government, because then there is a there will be a competitiveness among institutes, and it will be more. It will facilitate the more smooth investment process in control. Then participation of recipients of research output. That's research for society actually before, during, and after the commercialization and technology transfer process. All stakeholders should participate this commercialization and technology transfer process. For example, farmer may participate by giving his views and his experience to these things. So future implications, further analysis is in place to explore the practical implication of understanding the context, redressing the imbalance between using and practicing those KPIs, and role played by organizational leadership. Some implication for future research include in the extent to which psychological aspect of practicing KPIs in organizational design affect different organizations' relationship. Then how KPIs are differently shaping organization defined at the hands of leaders from different categories. For example, when a leader is at some age group, how a lower age group leaders are looking at these things, and how mature the very matured or old age leaders are looking at this likewise. So in conclusion, the outcome of the analysis facilitates developing a KPI key performance indicator, key performance drives framework to guide the organization thinking towards building commercially viable research for the society well-being. Also, it shall be instrumental in achieving the organization vision and mission through dynamic research, especially in the process of technology transfer and commercialization in commercial agriculture research based on informed decision acquired by KPI data and information. And this is our two of our papers, and you may refer it. And I think that is the conclusion. And thank you very much for listening. If you have any question, I think it may be late, I think. Okay, thank you very much.
Thank you very much, Dr. Abe Siriwardana. You have a very perfect time management. You made it less than 10 minutes. For the next speaker, we have Dr. Ahmad Gamal as Director of Innovation and Science Technopark or Advisor of the Smart City Research Center, Universitas Indonesia, Indonesia. In this afternoon, Dr. Ahmad will talk about towards demand-driven innovation, an example by Universitas Indonesia. He will present through a video recording. The organizer committee will play the video. Thank you.
Good afternoon. My name is Ahmad Gamal. I work for the Directorate of Innovation and Science Technopark here at Universitas Indonesia. And I'm going to present a presentation titled Towards Demand-Driven Innovation, an example by Universitas Indonesia. Allow me to share my screen. Okay, so hopefully you're now seeing my screen, and because I only have a very limited amount of time, hopefully there will be time for a short discussion afterwards. So this is us. I work basically under the Vice Rector of Research and Innovation here at Universitas Indonesia. And I work in an ecosystem in which we separate and differentiate between research and innovation. So basically, research is for basic research. Dede Johanna is basically my colleague who heads the Directorate of Research and Development, and basically I head the Directorate of Innovation and Science Technopark, where we basically commercialize the results of research done by our colleagues here at Universitas Indonesia. So this is kind of how we perceive innovation management to be able to basically respond to the market demand and creating innovations that is based on demand instead of just pushing our technology to the market. We basically see innovation as within the ecosystem of research and development. Research and development should not be started in a vacuum, right? So we do ideation events in which we seek for market demand information, and we also invite investments from our industry partners through research collaboration. And then we do assessments and valuation for the intellectual property that results from the research and development. And if they are considered as low risk, meaning that it's pretty easy to convince the market to purchase this new product, but it's capital intensive, then the decision will be to license that technology to our corporate partners. Whereas if the product is relatively high risk, which means that it's very new, and because it's very new, very novel, the market is probably very wary and very not easy to adapt to that product, but it's non-capital intensive, then we will suggest our faculty members to basically establish startups and spin-off companies that will in the end contribute to the university as shares. This is kind of the mapping of our funding. The innovation resources that we currently have at Universitas Indonesia. So university and the government provides up to 30 billion rupiah, about 20 million, about $2 million per year. Some industry funding amount to about 10 billion rupiah. That's about 700,000 US dollars. Some private investments up to 7.2 billion rupiah. And that generates a revenue of total about 700 billion rupiah. Commercially, we're pretty good. So the impact of our research and development has been licensed throughout the Java Island, which is one of the most populous and one of the most wealthy island in Indonesia. And we also, as of December of 2019, had about 106 startups as of December of 2019. So if you look at the kind of products that we have, you can see the diversity of the innovativeness of our inventors. From degasser tablets, this is the product that is very important for metalworking, to help metalworking to have a certain kind of density. Also in medical research, our inventors produce stem cells and medical devices such as the portable therapeutic photovoltaic devices. Also, we're very proud of our material engineers who work with medical doctors to produce biomaterials with metal bases, typically titanium bases, and other products as well. For example, geopolymer cements for sustainable building and stronger building materials, some cosmetic products, some biopesticides that is very contributive to the agricultural sector of Indonesia. So you can see the diversity and the variety of products and inventions that is produced by Universitas Indonesia, its inventors. I'm also very proud of the fact that our research and development results not only in commercial impacts, but also have a strong impact on communities. If you look at the distribution of community as benefactors of our technology, between 2017 and 2019, we have had a total of 430 programs that is distributed all over Indonesia. And all of these programs are basically programs that is disseminating, distributing our technologies to be used by the communities. Universitas Indonesia also have a very good relationship with the Indonesian government, where we produce policy brief series. And this is something that is very particular in the 2020, because in 2020, the pandemic hits, and there is a lot of uncertainty. There is a lot of needs for quick policy analysis, as well as quick policy recommendation. And we produced just within 2020 at least 31 policy briefs with a total valuation of between 6 and 10 billion rupiah. And also, within a very time-pressured period of 2020, we have produced very good interdisciplinary work where we created lots of innovation for the handling of COVID-19 in Indonesia. For example, we are behind the risk map of COVID-19 that is now published by the National Agency for Disaster Relief, or BNPB. We also produced, in a very quick time of 3 months, ventilators and have licensed them to one of the top manufacturers of medical devices in Indonesia, and is now available for purchase by Indonesian hospitals and Indonesian clinics throughout Indonesia. We also have innovations in artificial intelligence, where we help doctors to basically detect pneumonia as a result of COVID-19 infections. And this was, if you keep in mind, between March and May of 2020, testing, especially PCR testing, was very expensive and was very difficult to be accessed by the Indonesian population. So within that very short amount of time, we developed artificial intelligence-based diagnostic analysis for COVID-19 infections. So these are some of the examples of what we do. Basically, if you think differently, if you think instead of just pushing technology forward and thinking about the kind of needs that the market and the society has, I think there's a lot of example that will show that we will create a lot of impact. And that's really my point for this afternoon's conversation. Thank you very much.
Thank you very much, Dr. Ahmad, for the recorded presentation. Ladies and gentlemen, for our fifth speaker, we have Dr. Fatimah Rubaizah as head of unit from Malaysian Rubber Board, Malaysia. She will talk about natural rubber by Malaysian Rubber Board, or MRB, case study. Dr. Rubaizah, the time is yours.
Hello. Assalamualaikum and a very good evening to all. First of all, I would like to thank the organization committee for inviting me and accepting the paper for today's presentation. So as mentioned, my today's presentation will be on the specialty rubber commercialization, a case study, which this is one of the technology developed by Malaysian Rubber Board here in Malaysia. So in Malaysian Rubber Board, we do have various activities which involve industries and also universities. However, for today's presentation, it will only touches on the pre-com, TOT, commercialization. On the upstream, is actually showing a negative CAGR. This is due to the reducing plantation area in Malaysia, which also reflected on the midstream sector. However, for the downstream sector, which involves the rubber product manufacturing, is actually increasing year by year and showing a positive CAGR. So in natural rubber, the products that you can actually harvest from the tree can be in a form of field latex or field coagula, which these two materials later can be processed in the midstream sector to produce the latex concentrate, block rubber or clip rubber. This material later will be used by the rubber manufacturer to produce products such as tires, footwears, and also medical devices. What is actually unique about this natural rubber is because it has this good low temperature flexibility, high resilience, high tensile strength, good wind sparing, and also is very chemical reactive during the vulcanization process, which is very important in making rubber products. However, natural rubber do have its disadvantages, especially when it actually in contact with heat and oxidation. How we actually overcome these drawbacks in natural rubber is through modification. And one of the technology that being developed is known as the deproteinized natural rubber or epoxidized natural rubber, or commercially known in Malaysia as the Pioprena and Ecoprena. This is being conducted through physical and chemical modification. Why this specialty rubber modified natural rubber is very valuable in moving forward in Malaysian rubber industry is because it can actually touch various sectors in the ecosystem itself. First, on the sustainability, because it is produced from a renewable source. On the social aspect, this material able to increase the income of the smallholders, as in Malaysia, most of our rubber plantation owners are from smallholders, not the estate holders. And the features and also the performance of this specialty rubber also mimics the synthetic rubber material, where it can actually become an alternative material in rubber product manufacturing. And as the technology is owned and developed in Malaysian Rubber Board, we can actually customize the material according to the demand, and the quality assurance of the material are also maintained. So with that, we are looking into making this material to be the preferred material in sustainable sector, especially in niche rubber product application. So with that, this technology have been transferred to one of our company here in Malaysia, known as the Felda Global Ventures. And this factory is actually set up in one of the states in Malaysia, Negeri Sembilan, which is 250 kilometers away from Kuala Lumpur. And this factory having 4 reactors where this is actually needed for the modification process. And the processing capacity is actually at 3,000 tons per year. Doing this technology transfer and also commercialization, we actually look into the whole supply chain related to the natural rubber itself. So for the upstream sector, we try to support in actually building up a latex collection center, because the latex is actually needed for the modification process. And we also equip the smallholders with the latex collection tools. As for the midstream sector, aside from the technology that being transferred to FGV by building up the factory, we also give technical support and also testing equipment to ensure the quality of the material that being sold to the customer. And lastly, on the downstream sector, this is more related to the product development using the material. We collaborate with various rubber manufacturers and users in Malaysia, such as Proton, Nadicop, and Prasarana, as we wanted to show the potential and also the added advantages by using this specialty material. Aside from that, we are also filing up various IPs when we are actually conducting all this technology transfer and also commercialization, which involve patents, trademarks, and also utility innovations. Promoting and marketing also are being done, which also involve the exhibitions and also putting up videos promotion in various online platform, and also conducting interviews in local television station here in Malaysia. So this is actually the products related to the technology being transferred. As you can see on the left-hand side, that is the midstream, the rubber block and also the latex of the specialty rubber grades, where we can actually use it in various application sectors such as tire products, non-tire products, and also latex products. Currently, MRB already, with the collaboration with the industries, we able to actually come up with a technical specification for all this product, so it can act as a Bibles for them to actually refer later on when they actually wanted to use the material for each of the product. So this is just an outlook of the sales, production, also buyers of this material. Before the transfer of technology, we can see that the sales is around 300 and 400 tons per year. But after the transfer of technology, the sales actually pick up to at average of 600 tons per year. Yes, I know it's still not actually hitting the production capacity of the factory now, but as you know, in Malaysia, we also have the standard mentioned rubber, which is actually developed in 1980s. And now the sales of that material is already at a peak. So in order to change the momentum of using new material, it's still having a long journey to go. So we are still going into promoting this material to all the rubber products manufacturing and also users. So just an outlook on the potential of this material. If we see on the specialty or the eco-phenol latex concentrate, if we just targeted on the matrices sector only, where now it's actually dominated by the PU material, it actually have the potential to yearly contributing around USD 4.75 billion to USD 9.5 billion if we only tap around 5 to 10% of the market. And this is also reflected with the ENR latex and also LENR, where we can, if we touch on the adhesive, rubber sheet and paint, it also giving the potential of about USD 420 million to USD 630 million. However, we do have challenges, as I mentioned just now, adjustment of the current compounding procedures by the rubber manufacturers. We still need to assist them in giving some detailed in-depth of this new material in their product application. And lastly, currently, because this technology is only being transferred to one rubber manufacturers here in Malaysia, so the security of the demand is from the rubber product manufacturer is still there, because they are unable to take the risk if they start to change the raw material and suddenly the demand cannot be met. So that will be actually affect their business. So on the way forward, we see that we need to further expand this license of the technology to other company or even other countries. And we need to have a strategic sales and marketing to target niche application products as an alternative material for sustainable future. So I think that's all from me. Thank you.
Thank you very much, Dr. Rubaiza. The last but not the least, we have Dr. Pradip Samara Sekere as Senior Lecturer, Director from the University Business Linkage Cell, Faculty of Computing and Technology, University of Kelaniya, Sri Lanka. He will talk about bridging the gap between academia and business. Dr. Samara Sekere, I give you the time.
Thank you, Dr. Gultom. May I share the screen now? Hope you can see my screen.
Yes, we can see your screen. Thank you.
Okay. So thank you very much for this opportunity and organizing this event. For my presentation, I'm just briefly going to talk about bridging the gap between the academia and the business. So this is going to be somewhat different from what the other talks that we listened so far. So if I give you the background, I'm the director of University Business Linkage Cell of University of Kelaniya. So it is basically the similar entity to technology transfer officers that we see in most of the other countries. So I'm an inventor with a couple of patents and then an entrepreneur that we started the University spin-off company back in the United States and then funded through several grants through the federal fund. So basically what I'm sharing here is a kind of an experience that I had as a scholar as well as an inventor at the moment working as a administrative into the technology transfer and commercialization. So just to start with my discussion or the talk, I'll just briefly go through about the technology transfer ecosystem in Sri Lanka. Probably most of you might have about Sri Lanka because this is in Asian region. So in Sri Lanka, like we have a bit of a different situation at the moment. Like I heard the speeches from Indonesia, speeches from Malaysia, and several other countries, and it looks like most of the other countries, like you have the ecosystem to take the university innovation or the higher education system innovations into the commercial or the market level. But in Sri Lankan ecosystem, like we are still working on developing this ecosystem. I know like more or less like the other countries, you still working on this developing these ecosystems, especially in the Asian region, not unlike the European region or the US region. So back in Sri Lanka, like we just started the University Business Linkage cells. As I said, like these are similar to the technology transfer officers on the other part of the world. So we started all these UBL cells in 2016, and in Sri Lanka we have about 15 state-funded universities, as well as about 10 or less than 10 privately funded universities. So all these 15 universities are like spread out across the island, and we have all these UBL cells that working on technology commercialization of these the technologies that develop in these universities. And in 2018, like we got the funding from the World Bank project called the HEAD project, the Accelerating Higher Education Expansion and Development in Sri Lanka. So through that funding, we were able to get the operational activities of these UBL cells. So after like a couple of years, starting from 2016 and going into 2019 to 2021 now. So now we are onto the accelerated path of growing our technology transfer and technology commercialization. So as of now, we have developed our patent ecosystem within Sri Lanka, and now we are accelerating the patenting system, as well as at the moment we are into the filing of PCTs, as well as the other patents in the European region as well. So the innovation ecosystem in Sri Lanka, like if you take the ranking of Global Innovation Index, we are ranked number 14 among the 34 lower middle income countries, because we are just falling into the lower middle income countries, and among 5th of the other Central and Southeastern region countries among the innovation side. So on when it comes to the like the creative and knowledge creation from our side, like we are ranked above the most of the other countries in the region, as well as the innovation input to output performance are basically above the average level of the on the other countries. So what we are lagging behind is most of the infrastructure and the business sophistication. So basically, we're just trying to develop this business culture, or develop the culture within the business itself to support the university technology development ecosystem. So when it comes to the R&D, like I'm just showing up some of the numbers just to get an idea about like where we all are right now as Asian countries. On the right-hand side, what I have is some of the developed countries like China, Japan, Korea, United States. So how much that they are spending for the R&D from their GDP. So they are mostly onto the 3%, 4%, and even Korea just going into the 5% range at the moment. But as the developing countries, we Sri Lanka, I know Indonesia, Malaysia, and Thailand. And are also comparing that one with India, so it's on the left-hand side. So you can see like we are still below 2% of our GDP that we are spending onto the research and development. So this is something as I mean, as the policy makers and policy developers that we need to think about. If we want to get into the developed stage of the countries, like the countries that are spending money on the research and development, then we have to think about like getting the R&D support from the government side with the certain level of GDP from our GDP. So as I said, like in Sri Lanka, we are just setting up these ecosystems. So what we are trying to do is like we have the education system and the research culture within the state university system. So the education system basically onto the basic education, as well as the higher education and the vocational education system. So with that, what we are doing is basic research. So, or the fundamental research that we are doing at the university. So, but when we are going to move into the industry, when we are talking about the technology commercialization, there are two other pieces that we want to get in together. That is the innovation plus the industry. So the innovation comes into the applied research. So it is not the fundamental research that we are talking about or the basic research, but what are the research that we can take into the industry, right? What are the things that the industry is expecting, and what are the things that industries they are just fascinated about. If you just go and talk about like the fundamental research or the basic research, the industry won't like take that word, because that is not the language that they are speaking. So we as the academic, we need to bridge this gap. This is what I call the language barrier between the academics and the industry. So we need to bridge this gap, right? So what we need is a change of our mindset as the academics. As the academics, we need to change our mindset, because we need to talk about the business language. We need to speak in business language, right? Because if you just think about the academia, what we always see is like we are just trying to figure it out, what, how, why the things are happening, right? But when it comes to the business world, it is not like that. They think about, so what? I mean, you are just coming up with different ideas, so what? Who cares about that, right? Who cares about your fundamental research? If you can't sell this product, if you can't make money out of this product, then what the purpose of having this research work, right? So that is the fundamental idea behind the businesses. So if you want to get the industry involved into the academia, then there's a language barrier that we want to come across, right, as the academic. So this is what I call the translation of academia to the business world, right? So this is what I experienced from, as I said, like I was into the entrepreneurship, and now as a person that was working on the management side, I do see the problem with the academics, where academics always think about the fundamental questions, right? What it is, how does it work, why does it work, why it is, right? But when it comes to the business, as I said, who cares, right? So how can you, I mean, sell this product? Who's going to purchase this product, right? Can you make money out of this product? That is the language that the businesses talk about, right? And academia, we always, our research are context independent. We don't think about the context. We just try to find out some sort of a problem from maybe an previously published journal article or something like that. And we just try to come up with another research idea. That's all what we do, right? We don't care about the timing. On the point that we care about the timing is when there's a deadline for our grant proposals, right? At the moment that we have to submit the grant proposal, okay, now we have to work on a deadline. Otherwise, we are free birds. We don't think about the timing, right? We think about getting it right. It's true. Like we just want to make it perfect, right? Because we think like if we don't make it as perfect thing, then our reputation is going to be ruined, right? But when it comes to the industry, they are context dependent. They want to see what this exact research is doing, right? At the same time, the timing is crucial. The deadlines are crucial, right? So they need to run into the market windows, right? If you just miss, let's say like Meghan's and Harry's wedding, then if you want to put a product at that moment, then if you are missing that window, then it's that wedding is not going to happen again. That is the business context, right? Somehow get it out of the door and earn the profit, right? So as the researchers, we have to think about this mindset. So as a research, when we are even thinking about starting a research, think about these fundamental questions. What is the problem that I'm solving? Who cares about the problem that I'm solving? And how can I solve it to make it a better solution, right? And at the same time, think about why should someone put some money into your solution? And what is the return of investment of the money that they are putting in? That is the whole purpose of like the whole thinking behind the investors. If they don't see a return, then they won't think about putting a cent into your product. So as the researchers, there's a mindset that we have to change. So what I'm trying to emphasize here is, even most of the other countries, I know like there are research that we talk about the product that came into the market, but at the same time, just think about how much money that we are spending. Are we getting the return of investment? If it is only one product that we are getting into the marketplace from the entire research work that we are doing, maybe hundreds and 200 researchers, we are not having a good ROI. Think about it, right? So that is what I want to emphasize here. And this is the last slide. The Silicon Valley, this is where the language barrier is broken down. There are people who understand the business. There are people who understand the technology. So we need to think as the Silicon Valley. If we can think as the Silicon Valley, the entire world can make us a better place with the research, commercialization, and technology transfer. Thank you very much.
Thank you, Dr. Samara Sekere, for your presentation. Ladies and gentlemen, we have listened to 6 presentations, And now, according to the organizing committee, we still have time for discussion. So I think I will read two questions on chat. The first question is from Mr. Salim Mustafa to Mr. Mehtab from Pakistan. Earlier, you explained the data related to initial investment. And what about the data related to the profit obtained from the innovation? Can the private company benefit from the resulting product? And for the second question is to Mr. Bambang from ITS, from Mr. Salim as well. What about the continuation of the production of his innovative products? Does it have a good continuity of production and is very accepted in society? I'm worried that the product will be accepted in a short period of time or that it might not even sell in the market. As I heard about the seed product, it's one of the product owned by the ITS, which is said to be difficult to the market. I understand that Mr. Bambang and Mr. Ahmed already responded on the chat, but it will be great if both of you can elaborate your response to other participants as well. Thank you. Maybe for the first, I can give Mr. Ahmed first. Thank you.
Thank you. Thank you very much for raising the question. As I already told you, that it depends upon the product process. Which product the client want to commercialize. We invite them, we share with them the feasibility of the product. Suppose anyone interested to market the nutraceutical herbal product. When he come to us, definitely he already searched the market demand. We offer them the technology on very nominal charges like 0.2, 0.3 million on non-exclusive basis. Please mind, on non-exclusive basis, not for exclusive basis, because if we offer them exclusive basis, the mandate of PCSIR will die, because PCSIR intends to support many entrepreneurs or enterprises. We offer them to come in PCSIR. We offer them and allocate them the physical space on nominal charges, like as per Pakistani government policy, rupees 35 per square feet. Per month charges will not be more than for one product 50 to 60,000. Along with them, we support them in production, marketing, and registration of the products. In this regard, the investment of the parties will be reduced, risk factor will be reduced, because they have a mentor like PCSIR with him, guide him on each and every step. The second part of the question regarding profit. As per existing practice, PCSIR will not get more than 20% of the profit in the shape of royalty. Thank you.
Thank you, Mr. Ahmed, for your response. For the next question, I give Dr. Bambang the time. Thank you.
Thank you, thank you for the question. I guess I have explained quite along the chat box about the acceptance of some of the product. Just the example that I gave, as I said, the example that I show you is the few product example of few product that has been accepted by the society, and it's been still in the market for quite some time, and I believe it's going to last. And one of the examples that I explained is the ISO. It's very unique software is storage planning owned by not ISO, ITS, but similarly IS2 is also storage planning and first Indonesian software for storage planning, and it's been used in several SIP, and this is a new one, but the ICT has been in the market for quite some time, and the trend of the acceptance, the contract is rising significantly, so I guess it is going to last. And the example of cassette, that's true. Cassette is, I guess, the design of the cassette need to be rethink again. We have a new version of the electric vehicle that's going to come hopefully next year with this smaller vehicle, cheaper price, etc., etc. I guess what I would like to say, if we done the market research properly, and we know exactly what the market needs, then hopefully the innovative product that we have is going to last quite some time. But we also have a product that's actually answer to the current problem. For example, the pandemic. The pandemic requires us to substitute the nurse, such that the nurse is going not to have in contact with the patient quite often. So we developed a RISA robot. Probably the one from Indonesia has heard that we developed RISA robot to replace the nurse for COVID-19 case. And up to now, we have been able to market those robots. I guess it's more than 60 or 70 robot up to now over this past 1 year, and the cost of one robot is 200 million. It's surprising to us, but I don't think it's going to last unless we put another feature in the robot, not only for COVID-19 or infectious disease, but probably for something else. We think that probably the robot that we have not only to serve patient, but probably can be used in the restaurant as a replacement of waiters. Then we have to keep innovate. Otherwise, I'm sure it's going to die if we don't do a modification on that robot. But up to now, it's surprising to us too that it's been 70 or something, more than 70 robots in the market. Thank you.
Thank you, Pak Bambang, for your response. Ladies and gentlemen, I think we don't have any question anymore on the chat box. So finally, I would like to thank our 6 speakers for sharing their perspectives and insight of technology transfer and commercialization. And of course, thank you very much, ladies and gentlemen, for listening and for your kind attention. To all participants, you are kindly invited to proceed to the main room of the Zoom. Thank you and have a good afternoon. Stay healthy.
Thank you very much.
Thank you.
All the best.